The flow of electricity can be quite a beautiful thing.
It can also be quite loud, harsh, and downright irritating.
It all depends on how we use it. And to do that effectively, we need a good way to limit and control the flow of electrons. The most basic way to do that is with this, a resistor. You've probably seen resistors in one form or another. They can often be spotted by their cylindrical shape and colored stripes. In some more compact or surface mount circuits, they can be a little harder to spot, but they're still there, small, square, with a number label. In fact, nearly every electronic device uses some type of resistor. What they actually do is quite simple. A resistor holds back the flow of electrons to a certain degree. It resists electricity. And how does it do that? Well, the body of a resistor is made up of a combination of conductive and non-conductive materials. The amounts in this mix determine the value of the resistor, which we measure in ohms. In the early 1800s, German physicist George Simon Ohm began research using the electrochemical cell, an invention recently introduced by Count Alessandro Volta of Italy. Using equipment he constructed himself, Ohm began studying the behavior of electricity over various metal wire types. In 1827, he published his findings, and in them, he defined an important relationship between resistance, current, and voltage. Nowadays, we call this Ohm's law. It's a fundamental of electrical engineering. As resistors became more widely used, a system for labeling their values was needed. Because the parts were so small, it was expensive and difficult to print numbers on them. So instead, a color code stripe system was put into place. Each stripe stands for a number. Black stands for 0, brown stands for 1, red stands for 2, orange 3, yellow is 4, green is 5, blue is 6, violet is 7, gray 8, and finally 9 is white. These stripes are kind of nice because they have a way of visually livening up a circuit board. But anyway, you can make your own resistor using paper and pencil. A 2B pencil seems to work well. Try filling a space about 2 inches long very thoroughly. Get it just as dark and shiny silvery as you can. If you have a multimeter handy, you can test the value of your resistor, in ohms of course. This one turned out to be just under a half meg ohm. If you move your leads, then you've created a variable resistor. And what goes great with resistors? LEDs, of course. Multimeters are fun and all, but you'll probably want to put this thing into action. Connect the positive lead of a 9 volt to the positive lead on your LED, the longer one. And then hook up the ground negative connection off the battery to one end of your graphite resistor. Connect the LED's negative lead to the resistor, and you've got yourself a dimmer. Avoid connecting the clip and the LED directly together. Without resistance to limit the battery's current into the LED, it could burn out. Otherwise, good clean fun.